Design and testing of digital speed measurement system using optocoupler. So the circuit for measuring the digital speedometer looks like this. So it has an optocoupler. So optocoupler has an emitter and detector. So this is the emitter and this is the detector. So this is the rotating disc. The rotating disc looks like this is a disc, rotating disc, which is having a tooth. This is the optocoupler fixed there. In between this emitter and detector, the disc is rotating. So this motor is getting a power supply directly from the regulated power supply. So 0 to 30 volt is being connected, but we will be giving 0 to 14 volt only, not more than 14 volt we are giving to achieve the maximum speed. And you can see the next one is the optocoupler is getting a connection from a 15 volt power supply, and then the output of the optocoupler is given to the diode and a transistor arrangement, and the total circuit looks like a function of a Schmitt trigger. So whenever the emitter passes the light through the disc, then the detector is receiving the signal. Whenever it is the light are stopped by this disc, when there is a tooth, then the detector will not receive any output. So the output of the optocoupler looks like this, and it is converted into pulses. The rectangular pulses will be available at this point. You can see this is the same pulses in the CRO, which is connected here, and the same pulses are given to the dual triggerable bonus double multivibrator actually. So you have to design this resistor and capacitor value as per the design calculation given in the manual, and you can refer the pin detail on all the pins. You can refer and understand what is the purpose of each pin, and make the connection as per the circuit diagram. So, and the motor is getting a power supply directly from the regulated power supply to the motor, and let us see how it is working. Okay. So once if you give the voltage to the motor, the disc start rotating. You can see. So once I have given about 7 volt, the disc is started rotating. If you reduce the voltage also, it is slowly rotating. You can see. So you can see the function of the disc. So the disc is having so there are some space and there are some tooth. So whenever actually the light can pass through this place, but cannot pass through this particular portion of the disc. So therefore, when it is passing through the optocoupler, we will be getting a pulses. So this is the thing we should understand. So as the speed increases, as we increase the input voltage, the speed will increase. So at the same time, you can see the pulse width is also increasing. So I am reducing the speed. So you can see the large pulse width. So if I increase the speed, the pulse width is keep on reducing. So what you should do is, you just make the connections as per the circuit diagram, and keep increasing this input voltage, and the output voltage from the monostable multivibrator can be measured using the multimeter. You can see I have given a maximum of 14 volt. About 14 volt I have given. You can see the motor is rotating at a high speed. Then you can see the voltage of 2.6 volt, approximately 2.6 6 volt. So previous reading I am showing you. You just simply increase the input voltage for the motor from 5 volt to 14 volt, and you can see the speed is varying. This we have to calculate actually, and the pulse width you have to note down from the CRO. The output voltage from the multimeter you can measure the voltage. So first you should draw a graph between a speed and speed versus output voltage. In x-axis the speed is drawn, and in y-axis the voltage is taken. So the speed and voltages are directly proportional. And similarly you can see, so the time, this pulse width is measured in terms of millisecond. So the pulse width is inversely proportional to the speed. You can see as the speed increases, pulse width is keep on reducing. So the external resistor and external capacitor should be calculated using the formula given here. So the frequency is equal to number of tooth multiplied by the speed of the motor divided by 60. So capital N refers to the speed of the motor and the small n refers to the number of teeth. Okay, so from that if you assume the maximum speed of the motor is 1500 rpm and the number of tooth, you can count the number of tooths available in the disc and you can note down that, and you can calculate how much is the frequency. From the frequency you can calculate the time period. From the time period you can either assume the value of resistor or capacitor and then calculate the other value, which means if you assume the resistor value, you can calculate the capacitor value. So by using this resistor and capacitor, you can connect that monostable multivibrator and you can see the output voltage. Okay, after noting down the voltage, you are supposed to calculate the speed in every reading. So as the input voltage for the motor increases, the speed also increases. So the speed has to be calculated in this formula. The speed is equal to 1 by time period multiplied by 60 divided by small n, where small n refers to number of teeth. Okay, what is the time period? Time period is nothing but the time period measured in a CRO of a complete pulse. It is not the pulse alone, it's a complete pulse, which means the pulse, the starting point of the pulse and the ending point of the pulse. The entire pulse is calculated, and that time period you have to, that's what you have to note down. The same time period is used here to calculate the speed of the motor at a particular voltage.